Welcome back to the formulaic approach. Now in this video, we are going to be discussing circle theorems. My goal is that by the end of this video, you'll be able to solve all forms of questions on that circle theorem for WAEC and JAM. Is that clear? So, but for A levels, I will release another video on this same thing, but we'll treat more laws. But all the theorems we are going to treat here will suffice for your JAM and WAEC. Just make sure you're listening. Now, before we discuss the theorems, let us first discuss the properties of a circle, more like the parts of the circle and the properties. So, it has the first property you will notice here that it has a length. So, the total length of the circle is the circumference of the circle. The circumference is analogous to perimeter for shapes that have vertices. Okay? So, the total distance, I said, is what? Circumference. Now, if I move for any distance that is not the entire length of the circle, any distance on this circle is called an arc. So from here to here, for example, is called an arc. Is that clear? So the circle always has a center that produces the circle. So this is center. In your exam, you will see it always marked center O. Now, this small arc, this small distance here is called an arc, and because it's small, it's called the minor arc. The larger one here, from here to this place here, we call it the major arc. Is it making sense? Now, if I have another circle here, and I take a distance now, I take this distance from here to here, like we said, it's an arc. Now, if I extend that distance to the center. Now let me use this circle. I will do something different with that. If I extend this distance to the center, this divides the circle into what is called sector. This place, the small one, will be the minor sector. The sector is just the pie shape. Once you make a pie shape out of a circle, you have a sector. This one is called the minor sector. This is called the major sector. Alright? Now, so what I'm just saying is I have a pie shape here and a pie shape here. So these two pies make up my circle. I join them together. So those are minor sectors and minor sector and major sector. Okay? Now, look at this distance. What if I join them with a straight line that does not pass through the center? Now, this straight line is called a chord. Any distance from one end of the circumference to the other, any straight line that goes from one end of the circumference to the other, is called a chord. This is a chord, this is another chord, this is another chord. There is one that passes through the center. The chord that passes through the center is the longest chord, and it has a special name. It's called the diameter. The word di means two, so simply because it splits the circle into two equal halves. Okay, we have semicircles, so that's the longest chord. Now, what does a chord do? A chord divides the circle into two. Now, the diameter is the only one that divides the circle into semicircles, but every other chord divides the circle into minor and major segments. Minor, the small one is minor, then this larger one will be the major segment. Alright, so we know what a segment is, we know what a sector is, we know what an arc is. Alright, so this is an arc here, this is an arc here. Alright, so that said, then we can begin our circle theorems. Now, the first theorem we'll discuss is, now I'll not be writing on the board because I want us to be fast. Now you write, is a theorem that says that the angles subtended at the center by an arc, the angle subtended by an arc at the center of the circle is double that which that arc subtends at the circumference. I repeat that the angle that an arc subtends at the center is going to be double the one it subtends at the circumference. Let me show you what that is. If I pick an arc here, look at this arc, and this is my center O. The angle that this arc subtends at the center, if it subtends an angle at the center, it makes a pi, right? It makes a pi. So this arc here, and if you trace it down, you see that it's subtending an angle here, right? Okay. So the angle that is subtends at this center, it will be double the one it subtends at the circumference. Meaning that, let me clean this first and show you this same thing can also subtend an angle at the circumference. How? See it? The same arc gave us an angle at the circumference. So the angle that it will subtend at this center will be double the one it subtends at the circumference. Meaning that if I call the angle that is subtended at the circumference x, it means that here it will subtend 2x. It means that if it subtends x here, at this place it subtends x over 2. That is, the one it subtends at the center, that this arc gives you in the center, it will be double the one it will subtend at the circumference. Since it's the same arc, just trace it, you see it's the same arc, it's the same arc. Is it clear? Now, in your exam, you are not likely to see it this way. This one is sweet and easy to find. This way you will find it in your exam. Okay? So they will give you the center, they give you an angle x here, for example. Now, they will now give you something like this. Now, this is difficult to tell because you are not sure that this is angle subtended at the circumference, but it's the same. Watch. All you need to do is eyeball this. Notice that it is this arc that went inside here and gave us this arc here. See, give us an angle here rather. Do you understand? And it's the same guy that subtended an angle here at the center. So if x is here, then here at the circumference is x over 2. So another way to restate that axiom is that the angle subtended at the circumference is half of that subtended at the center by the arc. Do you want to do something? Do you need something?
No.
No. This place. Okay. Okay. So that's the axiom. That's the axiom basically. So this is the sort you might find in the exam. Now number 2, axiom 2 says that the angles in the same segment are equal. Angles in the same segment are equal. Angles in the same segment are equal. First, we need to know what a segment is, like I have said. Now, I need to draw a chord. If this is my center O, I need to draw a chord to make segment, right? So this is a segment, major segment. This is the minor segment. Remember, if this is a segment, this is the major segment, this is the minor segment. Now, angles that are subtended at the circumference in the same segment, they will be equal. I repeat, angles that are subtended at the circumference in the same segment, they are equal. So meaning that if I subtend an angle at this end here, I subtend another angle at this end here, because these angles are subtended in the same segment at the circumference. If this is x, this will also be what? X. They will have the same value because they are in the same segment at the circumference in the same segment. Is it clear? Angles subtended at the circumference in the same segment are equal. But you are unlikely to see it this way in your exam. The way you see it is this. The exam will normally clean this off and show you something like a bow tie. That's what they call it, the bow tie theorem. So the angle at this segment are equal. Now, keep in mind also that this place, if I join this end, this is another segment, meaning that if this part is A, keeping in mind that it must touch the circumference. If this angle is A, then this angle also be what? A, because they are angles in the same segment. Look at it. If I clean this part off, if I draw this angle rather out, and you know, you will see that this is a segment. This part is a segment, major segment, minor segment. So the angle in the same segment will be equal. This side will be equal to this side. Just like this side will be equal to this side. I told you in the exam, you will not find it this way. Let me show you another funny one that you might see in the exam. Now something like this will be given to you. Okay? This, and then you now see something like this. Now look at this. Now you are unlikely to think that an ordinary student is unlikely to think that this angle will be equal to this angle. Whereas they are actually equal because this here is a segment. This is a segment. So since this angle is at the circumference, this one is at the circumference, they will be equal. Is that clear? Likewise, this angle here and this angle here will be equal. Why? Because this is a chord. There's a chord there, and this is a segment. This is the same segment. This angle and this angle will be equal. Is it clear? Angles in the same segment, they will be equal. As far as you just use your mental picture to draw your chord here, and then any angle that is in the same segment at the circumference that way will be equal. That's axiom 2. Now let's go to the axiom 3 or theorem 3. Now, the angles in the same segment that you go now, angle in a semicircle is 90 degrees, is right angle. The angle in a semicircle is 90 degrees or right angle. What does that mean? I'm going to show you that it makes sense. Now, if I have my center O and I draw a diameter, once the diameter I have a semicircle, right? So the angle in a semicircle at the circumference is 90 degrees. What that means is that this angle here is 90 granite. This angle here is also 90 granite. In as much as it's touching the circumference, this angle here is also 90 granite. This angle here is also what? 90 granite. Do you see that? So, and let's make sense of it. We have already said that the angle subtended at the center is always double that which is subtended at the circumference by an arc. Look at this arc. If you reduce it to the center, it becomes 180 granite, right? So 180 granite is subtended at the center, at the circumference. Half of it will be subtended by the same arc. Look at it, it's this same arc that is making this angle here. So it will be half of this way, which is 90 granite. 90 degrees is that correct? Granite is degrees. Do you understand now? So angle in a semicircle is what? 90 degrees. Alright. Or you say angle subtended at the circumference in a semicircle is 90 degrees. Alright. Let's go to number 4. Now, axiom 4. Axiom 4 states that the angle that is cyclic quadrilateral, let's talk about cyclic quadrilateral. That will be, first, what is cyclic quadrilateral, not cyclic? Cyclic quadrilateral. You know, I've told you. See, one of the reasons why this channel is very good for those of you that are writing Japanese, I give you the right pronunciation of words. I give you the right, I speak the right, I speak correct English, okay? Here's the reason. You see, when you speak correct English that way, it's going to help you to you are going to be able to compare, juxtapose between situations when you see English in your JAM exam. For example, I was saying something in the one of my videos that if it were this, and someone asked if that English was correct. If it were, so it's correct actually, and that's a jam question where you use where in that's the subjunctive mood of if. Do you understand now? So subscribe to the channel. That's what I'm just trying. That's all I'm trying to say. Subscribe to the channel. Then there is one master's book that I told you about that you need. You really need it. Foundation master's book. Text me on my WhatsApp number. I'm going to give you the number of the publisher, and you reach out to him, to get it. It will be very useful for your WAEC and your JAM. I promise you. Like, it's one of the best textbooks you can find out there. I have my own copy, but I'm not with it right now. Okay? I have my own copy. I've showed you in my other videos. Alright, let's continue. So this is cyclic quadrilateral. Cyclic quadrilateral, not cyclic. Cyclic quadrilateral. Now, what's the cyclic quadrilateral? A cyclic quadrilateral is a shape that has four sides whose four vertices are touching the circumference. Vertices. Vertex is an edge. Vertices is the plural. So now, look at this. Look at this shape. You see, the four vertices are touching the circumference. So if that is the case, then this is a cyclic quadrilateral. Look at this other shape. Now, is this a cyclic quadrilateral? No. Although it has four vertices, but the four vertices are not touching the circumference. Only three of the four are touching the circumference. So this is not a cyclic quadrilateral. So the axiom I will give you here, the theorem of this will not apply to this. Is it clear? It is only when the four vertices are touching the circumference that you call it a cyclic quadrilateral. But like I said, in your exam, you will not see something as sweet as this. What you will see is something like this. For example, something so strange that you might not be able to, you might not easily attribute cyclic quadrilateral to it. Another one could be something like this. Look at this one. One will pass through the center, you find something like this, then like this, and like this. You see, there are four vertices here. 1, 2, 3. It's because my shape is somehow. But you see, it's still four vertices. So this rule applies here. Do you understand now? They always want to give you weird shapes so that you cannot easily attribute the correct theorem to it. Now, what does the theorem of cyclic quadrilateral say? It says, now you say, it's not it says, it says. Is that clear? That's why you have to subscribe. So the axiom says that you should that opposite interior angles of a cyclic quadrilateral are supplementary. Now, what are supplementary angles? I will link a video in the description where I just talked about triangles and lines. So see that video before you see this. The knowledge of that triangles will help you here a lot too. So I said that opposite interior angles are supplementary. Now we have two angles that we give special names: supplementary, complementary, and supplementary. When you say angles are complementary, when two angles add up to 90 degrees, they are said to be complementary. When the two angles add up to 180 Granot, they are said to be supplementary. So what this means is this: opposite interior angles, I repeat, cyclic quadrilateral theory. Opposite interior angles of a cyclic quadrilateral are supplementary. Opposite interior angles of a cyclic quadrilateral are what? Supplementary. So this place and this place, if I say this is A, this is B, this is X and this is Y, A plus B will be what? 180 Granot. Is that clear? As well as X plus Y will be what? 180 Granot. Is it making sense? So that's what the rule says. So opposite interior angles of a cyclic quadrilateral are supplementary. See. Now look at this shape. Now you see this one. Looks weird, right? How do you find opposite interior angles? If I call this M, I call this B, I call this C, I call this N. Which ones are opposite interior angles? Look at the way I scattered it. Actually, this and this are opposite interior angles. B plus M will be 180 granite. Is it clear? As well as N and let's call this E. N plus E will what? 180 granite. Is it clear? These are opposite. While these are opposite interior angles. Is it clear? Good. Now the fifth axiom is still related to cyclic quadrilateral. Now, listen. You see, this one is not like a special axiom. I'll just add it to this. Now, the thing with this other angle is this. It's just common sense. If you say that opposite interior angles of a cyclic quadrilateral add up to 180 degrees, what if I extend one side outside? I extend that line. First, that line will be called a secant. A secant is, now, you know this is a chord, right? Once I extend a chord outward, it becomes a secant line. A secant line. Exactly. Right. It's different from a tangent. I'll get there now, we'll soon get there. So now, we know that if I call this, we have to find x, and I call this a, I call this b, I call this y, I call this z. Now watch. Remember that we said a plus b will be 180 degrees, right? Opposite interior angles. Opposite interior angles also, y and z, 180 degrees. How do you find x? Very simple. Very simple. X will be exactly equal to z. Do you believe? Why? Because this way is also angle on a straight line. So since we have angle on a straight line here, and this plus this must be 180 degrees, angle on a straight line is 180 degrees. So if this plus this must be 180 degrees, then and y plus z is 180 degrees. Therefore, let me repeat myself. If y plus z is 180 degrees and y plus x is 180 degrees, then x must be z. If y plus z is supplementary, y plus x is supplementary, then if y and y are the same, then x and z must be the same. Do you understand now? So the way we state this axiom is that opposite interior angle of a cyclic quadrilateral an interior angle of a cyclic quadrilateral is equal to opposite exterior angle of the cyclic quadrilateral. Is it clear? An interior angle of a cyclic quadrilateral will be equal to opposite exterior angle. Let me show you now. If I extend this side will be equal to what? B. An interior angle will be equal to opposite exterior. Excuse me. Opposite exterior angle. Then these two, if I give you an angle here, it will be equal to where? Y. Is that clear? So that's that for the axiom. Now we have like 2 or 3 more axioms. Let me take order. No, let me finish this. Now, this one is having to do with tangent now. Now you see, this tangent, anytime you see a tangent, there are 2 possible rules that I want to ask of you. That's theorem 6. Now this theorem 6. Now, if you read advanced textbooks, you might not see this number 6 as number 6. So, okay, I'm only picking out the ones that you need for your exam. Exactly. You might see it as like theorem 22 or theorem 25. But we're calling that number 6 here. These are the ones you need for your JAM or WAEC, I promise you. In fact, even for some A-level questions, I promise you. Now, I said, a radius, listen, a radius is always a perpendicular bisector of a tangent of the tangent at a point on the circle. I repeat that. A radius always bisect, the way I said before, the radius is always a perpendicular bisector Exactly. So I now want to restate in another way that a radius always bisects a tangent at a point on the circumference perpendicularly. Exactly. It bisects it perpendicularly. Look at it here. It means that if I draw a radius at this point, anytime, first, what's a tangent? A tangent is a line that touches the circumference of a circle at one point. A tangent is a line that touches the circumference of a circle at one point only. One point only. So meaning that if I draw this line, you see it's touching the circumference at one point. So this line is called a tangent, not a secant. This will be a secant. By the way, if you have seen my video on introduction to calculus, you see I showed you the difference between secant and tangent. That was how the idea of calculus was developed. Howard. This is a tangent. You see, it's touching this circumference. Now let me draw a tangent here. Look at the tangent here. No. Let's manage it too. No. Once it enters the circle, it's not a tangent. Let's manage this one. So notice that this radius that I drew, it cuts it at the middle first, and it also creates I say it's a perpendicular bisector, right? Gives you a 90-degree angle. Perpendicular means 90 degrees. Perpendicular. Just now, 90 degrees. 90 degrees. So any point that you have a tangent, if you draw a radius to that point, it always touches it at 90 degrees. Somewhere 90 degrees. Is it correct? 90 degrees. 90 degrees. Now might not look very much like it's not because it's not drawn to scale exactly, but that's the way it is. It's always like that. And I mean, from what I even drew, you should be able to see it. For example, look at this. I draw another tangent there. If I draw a radius to touch it there, you see that it is 90 degrees. 90 degrees. Not perfect though, but it is 90, fairly perfect. Fairly correct. Okay? So that's that about that. Now what that means is this. Now I've actually made another axiom out of this. Anytime you see that, you see a tangent and there's a radius touching it, know that the angle that they will make is 90 degrees. The way you see in your exam is something like this, for example. You may see something like this. You will not be given the full this thing usually. So you now draw something like this, for example. You already know that this is what? 90 granite. Just now. So they might now make other funny shapes out here, make other funny things here. I mean, you can do this. It's very simple. Just what I'm saying now. So, you know, you already know that this is 90 degrees. So, that's that. Now, another axiom that we can make out of this one is this. You could call it Theorem 7. Is that if I draw two tangents from the same source, those tangents will be of equal length. Two tangents from the same source will be of equal length. I like to pick this side because there's space here. For your exam, you might see it from anywhere. You can see it from here. Okay, I can even draw it here, for example. Look at this tangent. And look at this. Now. Let's make it touch. Look at this tangent. Touching this tangent. They are from the same source. Their length will be equal. Once they are from the same source, they start from the same place. That's what it means. Their length will be equal. Now let me draw the one I said I want to draw. Now, since they are starting from the same source here, the length of this will be equal to the length of this. Is it clear? And I mean, of course, to add that axiom, then I now have a perpendicular bisector here. You know this 90 granules. Perpendicular bisector, 90 granules. What do you see is working here? 180 degrees. Do you see that? Then again, perpendicular bisector, 180 degree. Do you understand again? Do you understand now? Cyclic quadrilateral. Do you understand? This one is external now. This one is external. Exactly. All right. Now the next one. The next one. Let me clean that. So how do you say this? I said that tangents from the same point, tangents from the same point or from the same source are equal in length. They are equal in length. Length. They are equal in length. If they are equal in length, see another thing that JAM will do or your exam will do. They will cut it like this. So if they are equal in length, then it means that this angle was what? Equal. Using what? Base angles of an isosceles. What's an isosceles triangle? A triangle that has two sides equal, but the third side is not equal. This third side is not equal. That's me of this sign. This and this means they are equal. This double means it's not equal with them. You see, I put double here, meaning that these two lengths are equal to each other, but they are not equal to this one. Is it clear? And don't come using parallel lines, parallel line theorem, when you don't see an arrow like this. For example, I've seen a student do this. You did not see this. You don't see arrow. Don't use parallel lines. These two lines are not parallel. These two lines are not parallel, except you see this arrow. It means these two are parallel. Then you now see these two arrows here like this again. This is to show you that these lines are different from these two lines. Exactly. But these two are parallel, these two are parallel. Is it clear? Good. Now, let's now deal with the last theorem. Now, this is the last theorem. This theorem is the one that is most likely to come out. This is number 8. Okay? So, wait. Now, you can reach out to me for your JAM materials. Your JAM materials. Reach out to me for your JAM materials. I have them in bulk. All for your maths, your biology, your physics, your chemistry, your biology, your English, all the major textbooks you need. I have them in soft copy. Okay? Reach out to me on that WhatsApp number. Reach out to me. Okay, now this theorem is called the alternate segment theorem. This theorem always comes out when you have a tangent and a chord from a tangent. Once you see a tangent and you see a chord, you see a line go from that tangent to the circumference, well, you will definitely use this axiom. So once you see a tangent, there are two axioms that should come to your mind. This one and this here. I mean, of course, this one is derived from this one, right? Excuse me. Let me take water. So I said that you must see that axiom. Once you must use this axiom. Once you see a tangent and a chord, it's called the alternate segment theorem. It's like this: angles in alternate segments are equal. Angles in alternate segments are equal. That is, the angle. This is another way to state it. The angle that this chord makes with the tangent is equal to the angle that is made by another chord in the alternate segment. So look at this. Look at this. You will not see something as pretty as this in your exam. Exactly. So if this angle is x, what it's saying is that This angle will be equal to this angle here. Is it clear? And as well, this angle here will be equal to what? This angle here. So if this is A, this is also what? A. Does it make sense? So we call them alternate segments. This will be equal to this, this will be equal to this. This will be equal to this, this will be equal to this. In your exam, this is where you see it. You see something strange like this. It's not straight, but it's not as straight as what I drew. When I see your own chord here, for example, when I see your own chord here, your own tangent here, for example, right? And look at this. Then they will now maybe draw another, maybe a weird shape, for example, you know, at the center, that kind of thing. Very simple. See, all you need to do is this. This angle here, let me first wipe this off. This angle here will be equal to alternate segments. Do you remember? This will be equal to this. Same way this was equal to this. Is it clear? Then this whole place here will be equal to this whole place here. Is it making sense now? So that's the way to look at it. So even if they've added in weird shape, don't be confused. Don't be confused. And keep in mind, in fact, that if that's the case, these are clear. The angle it makes at the center will be double the one it makes here. So if it is x, this will be x over 2. Using the first axiom. Is it clear? Now let's go to solving questions. I'll pause the video. I'll write questions on the board. You attempt them first before I start solving. Exactly. We'll start from simple to complex. Alright. So I advise you to pause the video and try this. Okay? So I'm going to go on to solving it immediately. So pause the video and attempt the question by yourself. Attempt the question. So now, let's create a box for each question. Now this one, we can use the first axiom. It says that the angle that is obtained at the center is always double. We'll solve more questions. I see like some 3 or 4 more difficult questions that will now solve after this. But I want us to go from simple to complex. The angle obtained at the center is double the one that is obtained at the circumference by the same arc. So look at this arc. It's the one subtending this angle here, right? And it's the same arc that is obtaining this angle at the circumference. So the one it's obtained at the center will be double the one it's obtained there. So what that means is that the one it's obtained there will be half of this. So x is definitely half of 150, which is 75 granite. Is it clear? Very simple. Now, for the second one, it says the same axiom. The one obtained at the center is double that obtained here, right? So what? By the same arc, look at this arc that is here, this same arc that is here. Makes sense? So at the circumference, it is obtained half of what is obtained there. So this is half of something, right? So it means 2 times of this will give us what is here. Do you understand? Because 2 times of what is here, and 2 times of what is here is what is here. So 2 times of this is here. So here we have what? 128. So x is equal to 128 granite. 2 times of that. Then the third one, the same axiom. Now this one you have to look at it carefully. Now this arc, this big arc, subtended this big angle here, 240. So the same big arc subtended another angle here at the circumference. So that big arc is going to subtend half of what is obtained here. It is obtained here. So meaning that what is obtained here is double what is obtained here. So double of this gave this. That is 2 times of this gave this. So half of this will give this. So x equal to what? Half of that, which is 120 granite. See how simple those ones are. Now let's do this one together. the angle here, now the angle at the center is angle at a point, right? So sum of angle at a point is 360 degrees. Why do we need it? You know that this angle, this arc here, is the one subtending this angle here. And it's the same arc that is subtending this angle here. So the angle that is subtended at the circumference will be half of the one it's subtended at the center. So this x, if x is here, then it is 2x that is here. Is it clear now? So we can even use simple math to get this simple algebra. That is, at this point here, we have a circle, right? This is a circle here. So 2x plus 250 is equal to 360 granite. Is it clear? So this one goes here, we have 2x is equal to 360 minus 250. 2x is equal to 110. So from here, x will be equal to 55. That is divisible side by 2, right? 55 granite. Do you see that now? Or we first solve this by subtracting this from 360. Because this angle at a point, look at it, complete a circle. Complete a circle here. So sum of angle at a point or in a circle is 360 degrees. I've showed you why that is so in that video on lines and triangles. It will be in the description. Do well to watch it. So here, 360. So you have 250 minus 360, that is 110, right? So half of 110, 55. So here is 55. Is it clear? Good. Let's go to the next one. The next one, remember still, there is angle here is 140. Wait, is it this big one that is 140 or the one inside? Now, I want to assume that is the one inside. Yes, that's not. Okay, let's assume that. Do you know why I'm looking at it this way? I cannot say that this angle here is 140. Look at this one. Look at this angle. This angle is not as big as this angle. Look, this angle is bigger than this angle. And this one is 240, this one is 140. So maybe the question is referring to this one here. Do you understand now? So, but we'll solve it in both ways. You will now see that my assumption makes sense. So it's this angle here that is 140 granite. So if that angle inside is 140 granite, remember that it is this arc that made this angle here. It's the same arc that made this angle. It's the same arc that made this angle. Look at the way I'm tracing it. Do you understand now? So, if that's the case, these angles are subtended at the circumference. So, and this one is subtended at the center. So the one that is subtended at the center will be double the one that is subtended at the circumference by the same arc. So the arc that made here 140 granite will make here what? 70 granite. Because that will be half. Since they are in the same segment also, or it is the same arc. Do you understand? So those two axioms are linked. Say equal same segment axiom and that one. So it is this arc that is making this angle and making this angle. So x will be equal to y. So if x is 70, y is also what? 70. So x is equal to y, which is equal to 70 granite. Is it clear? But since this thing is not drawn to scale, if this outside one is the one that is 140, then you subtract from 360 to get this inner one. When you get the inner one, you will get 140, that's 220. So half of 220, which is 110, will be this place and this place. And of course, this place cannot be up to 110. So this answer makes sense. So let's leave it as this. For number 6, we have, look at this. This one is simple. We are given the segment. See, this is a segment here, right? So angle at this circumference here will be equal to angle at this circumference. So x will be equal to what? 50. Is it clear? Now look the opposite direction also. This is a segment here. Makes sense? So the angle, the angle at the circumference here. You know, by this arc, look at it by this arc. This angle here will be equal to this same arc entered here, right? 30. So y will be equal to what? 30. Then someone now say, Master, what of this place? Yes. This angle here, this arc here will make this angle here. So this segment there, we call it A. It will be the same as the angle that is made here. We call this one B. A will be equal to B. Is it clear? The same way, if you are looking at a segment from this chord, this arc is making an angle. If you call this place M, this M angle will be equal to this angle. Is it clear? Good. So, just rewind the video and see where I solved it. It's like that. Very simple. And I'm very sorry, my voice is bad. The next one. Look at this. This is a diameter. Once you have a diameter, you have a semicircle, right? So angle in a semicircle, 90 granite. Don't forget, it will be 90 granite. So if it is 90 granite, remember we're looking for x and y. So we already know this side 20, we know this side 90. So it means that 20 in this triangle, 20 plus 90 plus y plus 30. Do you understand now? There are three sides of this triangle, three angles will give you 180. Sum of angle in a triangle is what? 180. See that video in the description if you don't understand triangles and lines. So this plus this, 50 plus this, 140. So 140 plus y is equal to 180. So y will be equal to what? 40. This guy goes here. 180 minus 140, 40 granite. Is it clear? So this y here will be 40. How about x? The same proposition. Remember that angle at the circumference in the semicircle is always what? 90 degrees. This place and this place will be the same. Do you understand now? Now, this angle is 90 degrees. So to now get x, is x we are looking for. So x is in this triangle. Look at this triangle I'm drawing out. Look at it well. In this triangle, x plus 20 is one of the angles. X plus 20 is one of the angles. Plus this 90 granite here. Plus we have this place 30. Everything is what? 180. Some angle in a triangle. Is it clear? So 20 plus this 50 again. 50. Oh, you see that it's the same again. Because 50 plus this 140. X plus 140 is 180. X equal to 180 minus 140. X equal to 40. This is the same as y. Let's make sense of it. See. Segment again. You see they are in the same segment. This angle and this angle. You see that they are in the same segment. So they will be equal. You see that we've proven it again. Alright. Now let's go to this last one. Before we do three more. I've seen it is 3. Or 2. 3. Let's do 3. Look at this angle here. Now, we know that since we have this side, watch you. Here's what I'll just do. I have this side, right? This side. So from this segment here, this side will be equal to the same segment. This side is also 40. Do you see what I just did? Now, if that side is 40, watch. I know that cyclic quadrilateral, this place and this place will be 180, right? And of course, opposite exterior angle will be equal to this place. I mean, if this place add up to 180, 120 plus this thing add up to 180, and this thing plus this thing add up to 180, then it means that this place is 120. If this place and this place add up to 180, this place and this place add up to 180, these two places 180, it means that this place is just this place for them to add up to 180. Is it clear? So 120 will be this place. X and 40 is equal to 120. So x will equal to what? 120 minus 40, which is equal to what? 80. 80 granite. So x is 80. Let's see if we can use alternate segment to get it. We've gotten it. If this way is 80, then using this segment, same segment rather, this way is 80, then this place too. Y must also be 80. So y is also 80. Using what? Alternate, I'm going same segment. Is that clear? Right. Segment. Alright. I'll clear the board and write the 3 questions. Now, let's do this 4 together. It's very simple. Number 9, number 10, 11, 12. Right. So this one is very simple also. You see, this is 120 granite, right? We have to find angle ABC. That will be ABC. The angle at the center, here, that's where we are looking for. The one in the center is where the angle is. Exactly, the letter in the center, that's where the angle we are looking for is. So this is what we are looking for. Very simple. All we need to do is this. Angle at the point is what? 180 degrees. Angle on a straight line rather. This is a straight line. Look at it. Once it makes this semicircle, straight line, 180 degrees. So this place will make 180 degrees, means this place is 60. 60 granite. So if this is 60 granite, using alternate, angle is the same segment. Look at the segment there. This is a segment there. This arc will make this angle here. The same arc will make this angle here. So 60 here. It is also what? 60. So angle ABC what? 60 granite. That's all. Look at this second one. Very simple. This one says we should find M and N. I've told you. Once you find a tangent, very simple. The angle, the first theorem that should come to your mind is alternate segment theorem, and then that other tangent thing. Know that these tangents are from the same point, so the length will be equal. So if this is M, this must be M. Makes sense? But let's first find the M, right? Now, keep in mind that there's a chord touching, once there's a chord touching your tangent, alternate segment theorem immediately. This place will be equal to this place. So M is equal to 63 granite. This is what I just did. Very simple. So this place and this place also add up to what? This one and this place are equal, right? So this place must also be what? 63. This place is also 63. So and this is a triangle, right? So do 63 plus 63 plus N is equal to what? Supplementary. 180 degrees. So what do we have? 63 plus 63. That's 612. 126. Just now. So 126 plus N is equal to 180. So N equal to 180 minus 126. 130, 54. So that will be 54 granite. Do you understand now? So N is 54, N is. You can now use it to find any other side. Even keep in mind that, you see, this is radius. So this length will be equal to this length, meaning that this angle will be equal to this angle. Do you understand? Another thing is this. This is 63 degrees. You can use it to find it by doubling this. Meaning this is 126. I'm just solving other things. Then find this place. Do you understand? Then, if this is x, for example, this is also the x. So you can find it by saying 126 plus 2x will give us 180. So you do your thing. You get 54, divide 54 into 2. 27. So here is 27, 27. You see other things you can solve with that thing now. And keep in mind, this place is supplementary. Another thing, 126. That's another way to solve it. You've gotten this place, double this place, 126. Because angle at the center must be double that which the arc subtends at the circumference. So 126. So this plus this supplementary. 54. Do you see that now? Very simple and clear. The next one, or should we do the so let me clean this for this. You can pause video and always try it. Exactly, pause video and try it. Okay? Or maybe I should leave one for you to solve. Now let me solve everything. Text me on this WhatsApp number. I have an archive of about, I think, 70 something questions on this. It goes from simple though to complex for A-level questions. And if you can solve all those 70 something questions, there is no question you can also solve on circle theorem. So reach out to me on that WhatsApp number. Now I said that to solve this, very simple, it says you find ABO. So where is ABO? ABO. That's this side. Let's call it X. So we are looking for X. It's very simple, okay? It's very simple. Okay, now notice this, that these radius are equal. This radii that's plural of radius. Radii, they are equal. So it means this angle here will be equal to this angle here. Here. Do you agree? Okay, but that does not help us yet, right? I found what will help us. I found something that can help us. Watch. Notice that I found something that will help us. This angle here. Oh, once you see tangent, see, even I forgot. Once you see tangent, you are good to go. Perpendicular bisector. So this radius that is hitting it here is at 90 granite. This place is exactly 90 granite. So if it is 90 granite, and look at this triangle here. Some of them in the triangle 180. So we have 90 plus 35 granite plus this side. Plus let's call this side y plus y over 180 granite. If this place you want to find, just calm down. But it will help us to, so this side will help us to find that place. That's what we're trying to do. So this plus this 30 is 120, 125. So 125 plus y, we clean this place for it. 125 plus y is equal to 180. So y will be equal to 180 minus 125. 120, 130 is 50. 55. So y will be equal to 55 granite. So where is 55 granite? Here. Now look at this, look at this, look at this. We've gotten this place to be 55. We are done, we're almost done. Look at this arc. It's subtending 55 at the center. Then the same arc will subtend at the circumference. Half of this. What is half of 55? Half of 55 is what? 27.5. 54 is 27 now. So that will be 27.5. So let's call this place Z. So Z will be what? 27.5. So if Z is 27.5, watch. And Z is this place made up of this angle, this triangle rather, is made up of this side which is 42 plus this side which is Z plus this entire place. Let's call this entire place M. M is made up of, let's call this place no longer X. Let's call it A and B. M is made up of A and B. Everything will give us 180. And Z, we found it to be 27.5. So 42 plus 27. I'm sorry, my voice is bad. It's becoming good in Jesus' name. So this plus this is 69.5. 69.5 plus M is equal to 180. Equal to M M will be equal to 69.5 from 180. 70 is 10. 70 is 110. So minus 0.5. That will be 101. 110.5. 110.5. So M is 110.5. Right? M is 110.5. And we're looking for this B alone. But we've got everything here. Remember that A plus B will give us 110.5. So we need to find A to be able to get B, right? It's very simple. What will I do now? It's very simple. I found out another thing. Watch. You know that this place, can we use alternate segment? Can we use alternate segment? This place, we're done. Okay, this place, because there's a chord, there are two ways I can solve it. But the first way is this place will be equal to this place. Alternate segment. You see that? So 110.5 here. And everything here. Does it help us? No, it doesn't help us. It doesn't help us. So because what that place will find us is this place. Do you understand? Okay, you can still use it to find that one, but let's not use it. Let's not use it. Let me show you what we can use. See, it has become rough, but let's manage it, okay? See, we are looking for this place, and this entire place is 110.5. I hope I've not lost you. Now watch. This place, because it's radius, this place will be equal to this place. So A is the same as, this A is the same as 42 plus a particular guy here, plus a particular X. Do you understand now? So we need to find our X. How do we find our X? Do you know that if we have found the X, we have found our answer? Because, no, okay, we have not found our answer. No. We have not found our answer. So, let's call this place the X. So 42 plus X will be the same as A. Because they are made up of the radius and the same radii. Equal length of the length of the radius is the same. So we've got this is 55. It's very simple now to find X. We know that 55 watch 55 plus these two places. If this place is A, then this place must be A, like we just said, right? It will be 180 inside this triangle. Just now. So 55 plus 2A will go to 180. So 2A will be equal to 55 plus subtract from 180, 55 from 180, you get 125. So A will be equal to 125 divided by 2, which will be what? 124 is 62. That will be 62.5. So A is 62.5. So if A, we solve this, right? Let's clean it. Yes, we solved it. A is 62.5. And we said that A is 42 plus X. So X will be equal to 62.5 minus 42. That gives you 20.5. So X is, so that's this X. Okay. No, we don't even need the X. It's B we are looking for, right? So, and this entire place is 110.5. So 110.5 is equal to this A plus this B. And we got A to be 110.5 is we got A to be 62.5 plus B. So B will be equal to 110.5 minus 62.5. 0.5 will cancel 0.5, that was 0. 110 minus 62. 60 is 50 for 110. 62 to 48. So the answer is 48. B is 48. So this place is 48. Is it clear? You see, if you understand those axioms well, you can solve it another way. There's another way I can solve it, and we'll still get the same answer. For this one, it's also very simple. In fact, one first thing I'm noticing is the diameter here because it's in the hole. So this way is 90 granite. You see? Sorry, 90 granite. 90 granite. So if that's the case, then we also know that watch. Let's call this place, let's call it A, let's call this place. If this place is A, this place will also be A. Why? Because it's the same radius. Is it clear? So 2A plus 76, that this plus this plus this is equal to angle in a triangle. So 2A is equal to 180 minus 76. So 2 equal to this minus this. 70 is 110. 6, 4, 104. So over 2 over 2, A becomes, you use your calculator, okay? A becomes 52. So this place is 52 granite, and this entire place is 90. So 52 minus 90, and Y plus 52 is 90 granite. So Y will be equal to 90 minus 52. Y will be equal to 38. Excuse me. 38 granite. This is the way I found it. It's as easy as ABC. Now also, note that alternate segment. Once you see a chord and a tangent, alternate segments work. So this place will be equal to this place. Makes sense? And this place is 90. Make sure you have copied this. This place is 90 plus this place. Let's call that place Q, for example. D, for example, plus this place A. We got A to be 52. Everything will give us 180. So D will be equal to 180 minus 142. D will be equal to 38. We got 38 just now too. We got 38 somewhere. Why is 38? Oh yes! Because this is equal to this. It's radius. Do you understand now? You see, mathematics does not lie. So this is 38. So we're looking for x now. So x must also go out 38. Very simple thing. So now find y. Z. That's the easiest. Now this one I'll leave you to do it. Put your answer in the comment section. Let me teach you what to do. We are going to use opposite interior angles. Vertically opposite angles are equal. So Z must be equal to this place, to Z. So what do? We have found X. Find this place. How do you find the place? Since this is a straight line, you already know this place. So subtract, you get this place. So do that, 180, and you get Z, which is equal to this place. Drop the answer in the comment section. And put circle theorem. I love you. Do want to subscribe to the channel and share the video with your friend. Like and also share the video. God bless you as you do so. See you in another video.